we learned that instead of plugging in a number on Friday into the function and getting an answer, you could also do something called synthetic substitution and plug in that number, and your remainder is the answer, right? So today, Kinley, what we are going to do is we are going to use the remainder theorem to evaluate f of x at c. Now, if something is a factor, look right here. If something is a factor, what is another name we could call? If x minus c is a factor, what does c equal then? A 0. C is a 0. And so if c is a 0, don't you agree that f of c would equal 0? Which would mean the remainder should be 0. That is what the factor theorem says. If you have a factor and you plug it in and use synthetic division, then your remainder should be 0. And if it's not 0, then what does that mean? Well, it's not a factor. It doesn't work. It's not a 0, right? It's not an x-intercept. I don't know why this is at the bottom, but I want you to come to the bottom right here. So what I just summed up, again, Kinley, turn around, get your packet out, let's go. If R is a remainder obtained by synthetic division, f of x by x minus c, then the following statements are true. R is the value of f of c, y'all agree? And if R is 0, then x minus c is a factor. If x minus c is a factor, then what do we know about c? It's an x-intercept. What's another word we use for x-intercept? A 0. Or you could also say that c is a solution at f of x equals 0. Any of those, that's all saying the same thing, those last 3 bullets. They're all saying the same thing. Yes. Yes. 100%. Next Tuesday. Not at all. It's not Friday on purpose. We moved it up so we didn't have people missing stuff so I could grade before spring break. So your test is next Tuesday. Are you going to be out next Tuesday? Yeah. Yeah. Tomorrow? No, next Tuesday is the test. Not tomorrow, next Tuesday. Yeah. Okay. All right. So let's use the factor theorem. Hold on. Focus, please. Shh, come back. Let's use the factor theorem and see if this works out. So right here, I have this long polynomial. I want to know if x minus 1 and x plus 3 are factors. So we can test them out. I'm going to take that phone away. So what would be the first 0 that we try out? X equals 1. Do y'all agree this is x equals 1? So I'm going to plug in 1 into this. So I get 4. My coefficients, y'all remember we did this last Friday. And then we are going to drop it low. No, drop it down. Multiply, add, multiply, add, multiply, add. I'm just kidding. I'm trying to see if y'all are paying attention to me. What's 4 times 1? Do y'all agree that is my remainder? Is that 0? This does not equal 0. Therefore, what does that tell me? X minus 1 is not a factor. What else do we need to try? X equals negative 3. So you try negative 3 now, please. Look up when you're done. Yeah. Does it equal 0? Yeah. Yes, therefore what? X plus 3 is a factor. And I didn't read the instructions real quick, so I'm going to read the instructions. It says use the factor theorem to determine if the binomials are factors. We just did that. And then use the binomials that are factors to write a factored form f of x. So now, what is my f of x going to equal? What's my factor? X plus 3. Why did I just write 4 but say 3? X plus 3. I don't know why I'm thinking about 4. And then, oh, that's why I wrote 4. And then what is the rest of my equation? So this is called your depressed polynomial. It's not depressed, but it's depressed meaning shortened. So what is your other factor going to be? 4x cubed plus 9x squared plus 1. How do you know that first one's going to be 4x cubed? It's going to be 1 less, but also this is a constant x squared cubed. So you can also do that. What questions do I have about this? Ask me. We're okay? All right, for the next one, it's the same thing, same questions. So the first one I'm going to try is what? Negative 4. X equals negative 4 would be the 0. Drop it down, multiply, add, multiply, add. Is this a 0? Yes. So therefore, x plus 4 is a factor. Now pause. If you get a factor right off the bat, you can now use your new depressed polynomial to check the next one. You do not need to use this one. Could you use this one? Sure, but I'm going to show you what happens when I use my new depressed polynomial for the next one. So it's shorter too because you're using less numbers, right? Drop it down, multiply, add, multiply, add. Is this one a factor? Why would we want to use our depressed polynomial? Because it just factored it for us now. What does f of x equal? What are my factors? X plus 4, x minus 5, and then what's left? What's the final depressed polynomial? 2x plus 1, and it factored it all the way for you. So that's why we like using the depressed polynomial. Yes. 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 Put a 0 placeholder. Correct. No. So this is now in factored form. Now, do you see how I gave you the factors and I asked you if they worked? Am I always going to give you the factors? No. Turn the paper over real quick. Oh my God, what a bunch of babies. All right, so could I just sit there and guess and check? Yes. So what we're going to do real quick, we're not guessing and checking, we're just starting it off. What I need you to know is in order to figure out what the factors could be, you are going to have to do the rational zero theorem. I just need you to underline real quick. P, circle P. I don't mean underline, I mean circle. P is your constant. What is a constant? No x. So in this equation right here, which one's P? negative 9. Everybody box Q. Q is your leading coefficient. So which one will be Q here? The coefficient in front of that is 1. That is my Q. So, P will be negative 9. Q will be 1. All right, identify P and Q on this one. What does P equal? What does Q equal? P is 8. Q is 3. You think that's pretty basic, right?
Yeah.
Tell me why every year I get kids missing that. P is your constant. Q is your leading coefficient. Tomorrow, we're going to take this a step further, and we'll do this. We're not doing anything else. So, all right. Again, if you have not already,